Hello guys, welcome back to your favorite and India's most affordable learning platform, PhysicsWala. So in today's session, we are going to cover the next lecture of motion in a plane. So where we are going to cover projectile motion from some height and projectile motion on an inclined plane. So in the last lecture, that is lecture number 7, so where we have seen the projectile motion's equation of trajectory and some questions related to that we solved in the previous session, right? So today's session, it's going to be the last lecture of your motion in a plane lecture chapter. Okay, so as usual, for the next 1 hour, just be with me, avoid all the disturbances around you guys, and at the end, it's very important to prepare your own short notes. Chalo. So let's begin the interesting session today. So the projectile motion from some height. So till now, whatever we have studied, the projectile motion from ground to ground. Yes or no? So what does it mean by ground to ground? So when you throw an object from the ground, so again it reaches to the ground. So then it made the trajectory like this from ground to ground. But just imagine if you are standing on a building. Okay, if you are standing on the top of a building, so then you are throwing some object from there. Okay, so let's consider first you are throwing it some horizontally. Okay, just imagine you are standing on your building. Okay, and then you are throwing a stone like this, just horizontally. So then how the stone will take the path? So it takes this projectile path, so it goes horizontally for some distance, then it takes this path. So that's a projectile path again. Yes, so the projectile motion from some height. See here, that's what. So here is a person, let's suppose the Chintu is standing here and then he is moving here straight, and then so this is a path of the body followed. So here if you consider, there is no vertical velocity. Initially he is just throwing with some horizontal velocity. Shall I say that this uy is equals to 0 here? The velocity in the y direction is 0 initially. Yes or no? He applied only the horizontal velocity just like this. So there is no vertical velocity. Uy is 0. So now, so to find the maximum height, however, it's going to be same, h. Yes or no? What is the maximum height? Because he is throwing horizontally parallel to the building. So that's why this is going to be the maximum height. So now the question is, what is time of flight and what is horizontal range? So first let's find what is time of flight here. Let's find what is time of flight. See, first thing is to understand the time of flight, we take the y direction motion. Yes or no? So we derived many formulas till now. So now in the y direction, the initial velocity is 0, and you know that ay is equals to minus g. And then see here, the distance in the y, it's going to be so minus h. Why? The body is initial position is above the final position. Here, from here you are throwing and then it reaches here, so that means its initial position is above the final position. So that's why sy is minus h. So let's suppose it has taken some time t is equals to t. So that's what we have to find. So now I am using sy is equals to uyt plus half ay t square. So from here, so what is sy? Sy is minus h. So this term will become 0. Half ay is minus g, right? So then t square. So from here, so t minus cancel. So t square is equals to 2h by g. From here, the t is equals to root over 2h by g. So the t value is root over 2h by g. Have you ever seen this equation? Just recall the previous lectures once. Guys. Is this formula familiar to you? What is this formula? The time taken by a freely falling body from some height, what is that formula? T is equals to root over 2h by g. So here the conclusion that we have to remember here, the important conclusion where the direct theory questions are asked many times in the many state level examinations and JEE as well as NEET as well. Okay, so what's the conclusion? So if you drop a body, for example, this is of some height building, so then from here you are just dropping a body is dropped. So then let's suppose this is the height h. So then what is the time taken by this freely falling body? So the time taken is equals to root over 2h by g. So this is the time taken by a freely falling body to reach the ground, yes or no, from some height. And so now one more same formula for which one? The projectile motion from some height. So when you throw a body from here, so then it takes a path like this, right? So then what is the time taken to reach this point? Again in this case also it's going to be root over 2h by g. So now how they will frame the questions? So a person A and person B are standing on the same building, and then person A has just dropped the body, and person B simultaneously thrown some body horizontally with some horizontal velocity u. Okay, so now which body reaches the ground first? So the time taken by the first body, root over 2h by g, which is freely falling. The time taken by horizontally thrown body, root over 2h by g. So therefore they both reach the ground simultaneously. So let me take the question which was asked previously on this concept. See here. So this question says that a particle A is dropped from a height and another particle B is thrown in horizontal direction with a speed of 5 meters per second from the same height. See here, from the same height. Yes or no? It just depends on the height. T is equals to root over 2h by g. G is however constant. So the time taken is just depending on the height. So whether you just freely dropping it or you are throwing with some horizontal velocity, that doesn't matter. Only the height matters here. T is equals to root over 2h by g. So as they both are, one is dropped and one is thrown, so from the same height. So that's why the both particles will reach the ground simultaneously. Both particles will reach the ground simultaneously. That's the only option you should look for. Clear? So this is the hint given. Understood? Sure. Next. Chal. So next, how do you find the horizontal range for this? So the horizontal range is nothing but in the x direction we consider. So this is a r, the range is a r. So now simply again the initial velocity in the x direction is u. So you know that as the velocity in the x direction remains constant throughout its motion, so the ax will become 0. So let the time taken be is equals to the time of flight, or let it be so capital T. So then the range, so the distance traveled in the x direction, let it be r. So then again I am using the s is equals to ux t plus half ax t square. Yes or no? So from here you could see that this term will become 0 because the acceleration in the x direction is 0, the simple thing. And then so what is the range here? R. So then ux is u, so into, so the t is time of flight. So simply I can write r is equals to u into root over, what is the time of flight? So root over 2h by g. See, just follow the basic procedure. You need not to by heart these formulas. Just follow the basic procedure, that's it. Okay, I am not remembering any formulas here. Okay, understanding? Just I am following the procedure, I am getting the answers, that's it. Clear? Chal. So for this projectile, if you want to find velocity at some point, let's suppose here, if you want to find the velocity at some point, so in the x direction the velocity remains same, the ux is going to be u. The horizontal velocity, it's going to be constant, it will not change, ux is equals to u. So but what is uy? So the ux is equals to u. So then sim is in the y direction, the initial velocity is 0. You know that how much distance it is traveling in the y direction. So let it be the I can use simply v is equals to u plus at. Vy is equals to Uy plus Ayt. So from here in the y direction, so the velocity in y is equals to initial velocity in the y is 0, Ay is minus gt. So therefore the Vy is equals to minus gt. So simply I can say that, so when the body reaches this point, so its horizontal velocity Vx, let it be, which is u. So the vertical velocity, so that is Vy. So that Vy is minus gt. Overall, what is the velocity? Let it be some point P. So what is the overall velocity at point P? So in the x direction, it is u I cap plus, so in the y direction, it is minus gt j cap. So minus gt j cap. That's it. Yes or no? So the simple thing. This is the velocity at some general point. Yes or no? So now, so if you need what is the speed at that point, so you can find speed. So which is equals to simply, so the square root of u square plus minus gt whole square. That's it. This is the speed at that point. So or let's suppose if it is making some angle alpha with respect to x axis, so then you can find the tan alpha also. So the tan alpha is equals to from there, so the Vy by Vx. So the Vy by Vx. The same procedure, that's it. Whatever the procedure that we have followed previously to solve these derivations, the same procedure I am following. So when the body is projected from some height, so the time taken will be same as of the freely falling body from some height, which is t is equals to root over 2h by g. And then, so to find the horizontal range, just use the procedure. And then, so to find velocity at some general point, so just use the general procedure. And then if you want to find the trajectory equation, so how do you find the trajectory equation? Trajectory equation means the path followed by the projectile, right? So it should be independent of t. So what you do? So let's take the x direction. Am I going fast? See, already these are known things. That's why a bit faster only I am moving. So if you are not understanding, just let me know. So again I will slow down. Okay, chal. So in the x direction we have got what's in the x direction the initial velocity is u. You know that the acceleration in the x direction is 0. So and then the distance traveled in the x direction, let it be x to reach this point. So let this be point P. So to reach this point it traveled some x distance in the x and some y distance in the y. Yes or no? So therefore, so let the time taken t is equals to t. So you know that Sx is equals to uxt plus half axt square. So here as ax is 0, so this term will become 0. So the Sx which is equals to x, ux, u into t, let it be t. So let it be aside. So now next, so next I can write here. So in the y direction, so in the y direction the initial velocity is 0. So the ay is equals to minus g, and then the distance covered in the y to reach this point P is minus y. Yes or no? So which is going to be y, and then what else is given? Sy. So let's take it as minus y because the final position is below the initial position. And what else is given? Ay. So let the time taken be t. So again same use of procedure. Sy is equals to uyt plus half ay t square. So from here, so let me write. So what is sy? Minus y. Uy 0. So this whole term will become 0. So ay half ay is minus g. So let it be t square. So here minus minus cancel. So y is equals to, I can write half g into, so in place of t, so I am writing x by u. Here t is equals to x by u. So in place of t, let's write x by u whole square. So therefore y is equals to half gx square by u square. So the y is equals to half gx square by u square. This is a trajectory equation. So you need not to remember any of these formulas where of projectile motion from some height. Just understand the procedure, that's it. Clear? Because here the values will be given to you. You just have to substitute the values. Okay, in the procedure. Chalo. So let's take one question. So what's the question says? A projectile is fired horizontally with a speed of 98 meters per second from the top of a hill 490 meters. So let's suppose this is a hill which is 490 meters. So this hill is of height 490 meters. So then horizontally a projectile is fired horizontally from here. A projectile is fired with a speed of 98 meter per second. So then what they are asking, so the first question, time taken to reach the ground. So the first question is pretty easy. The time taken is equals to root over 2h by g. So simply substitute it in the formula. So 2 into h, 490 by 10. Yes or no? G value they strictly said. So let's take 9.8 itself, because they said 9.8 in the question, right? So then this is going to be some 980 by 9.8. So which is 100 times, yes or no? So this is 100 times. So which is nothing but 10. So the time taken is equals to 10 seconds. So simple question. So and then the second part is, so what's it? We can write the time taken, so what's the range they are asking. So see here, the distance of the target from the hill. Distance of the target means it is projected from here. So then let's suppose the distance is the target is somewhere around here. So which is nothing but the range, yes or no? So we have to find the range. Let's suppose the target is here, it hit the target and again it falls down. Okay, so therefore whatever the till the distance it covered, that's a horizontal range they are asking. So to find the horizontal range, what I said, so the initial velocity in the x direction is 98 meter per second, let it be. So then the acceleration in the x direction is going to be 0. So and let the time taken is equals to 10 seconds. So the total time taken is equals to time of flight. So that's it. So use the formula, need not to remember any formula, just use the basic concept. So Sx is equals to uxt plus half axt square. So from here this axt term will become 0, yes or no? You have to find this range. Sx is equals to ux, so 98 into what is time of flight, so which is 10. So simply this is going to be 980 meters is a range. Understood guys? So you just follow the procedure. Okay, clear? Sure. So now projectile motion from some height, from a height at some angle. So till now whatever we have seen, the projectile motion from some height when you throw the object only with horizontal velocity u, yes or no? So in this case the maximum height remains same, h, and then the time of flight is equals to root over 2h by g, and the range will be equals to, so uxt plus half axt square. Simply you can write u into horizontal velocity into root over time of flight is root over 2h by g. This is the range, and then velocity at some general point p, which is equals to u I cap minus gt j cap, and then the equation of trajectory y is equals to half gx square by 2 u square, right? So half gx square just now we have seen, right? So half gx square by u square. Half gx square by u square. So these are the formulas that we have seen when the body is thrown from some height, but just horizontally, there is no vertical speed. But if you throw with some angle, if you throw with some angle from some height, this is the height, so then the body takes, so it goes like this and then it lands this way, yes or no? So here you just follow the procedure. So in the x direction and in the y direction, that's it. So to find anything you just follow the procedure, whether it's time of flight or maximum height or anything. So to find that, just follow the basic procedure. So in the x direction you know that ux is equals to u cos theta, and then the ax is equals to 0, yes or no? The horizontal component of velocity remains constant, so that's why, so ax is going to be 0, right? So and what else is given? So the distance covered in the x direction is going to be the range, yes? So then what so here if you want to find, so what is range? Sx is equals to uxt plus half axt square, simply. So then here axt square term is 0, so the Sx is r, which is equals to ux, which is u cos theta into the t. So t is the time of flight. So t is the time of flight. So if you want to find the time of flight, see here, if you want to find the time of flight here, so how do you find y direction? You can take time of flight for time of flight. So if you need the time of flight, so what we do? So we take the y direction motion. So what is there in the y direction? uy is equals to u sin theta. Yes or no? You thrown with some angle theta here, so that this is u cos theta, this is u sin theta. So therefore uy is equals to u sin theta, and then ay is going to be obviously minus g, and then the distance traveled by the body in the y direction is going to be, this is the initial, this is the final. So the total displacement is minus h only. So the total displacement is minus h only. Yes. So simply you can use sy is equals to uy plus half ay t square. So in place of t, you can substitute r by u cos theta. So the formulas will be lengthy, no need to remember, but just I am saying you to understand the procedure, that's it. Just understand the procedure. So from here you can use the equation sy is equals to uyt plus half ayt square. No need to derive the formula, don't do that. No need to derive the formula, so don't take the formula. So just understand the procedure till here, and then this procedure to find the range. And if you want to find the what is the height, so consider this as ground to ground projectile motion from here to here. So can you find what is the height here? Yes or no? So this height plus the building height, so that will be the total maximum height. Yes or no? See, from here to here, can you consider this as a ground to ground projectile motion? Consider here it is the ground. So you know the e cos theta and you know the u sin theta. From here to here, can you find the h max? Yes or no? So the basic thing. So then you add this height to the building height. So that will be from ground. If they ask maximum height from the ground, so the h plus this h max. Done? Clear? So I am giving you, so this question which is based on the previous topic. So take this question as a homework, guys. Everyone. So try seriously. Simple question, so nothing to worry. You just have to follow the procedure, that's it. Just follow the procedure. Okay, so take this question as a homework and comment your answers. So there are total 5 questions in it, 5 sub questions are there. So you have to answer these 5 sub questions. Okay, just a minute, guys. Understanding? Clear? Chalo, next. So let's move for the next concept, that is projectile motion on an inclined plane. Okay, so you take this question as a homework. So the values are visible, right? This is 11. So here it is thrown with 10 meter per second. So at an angle 37 degrees. Have to find speed after 2 seconds, time of flight, horizontal range. So the maximum height attained by the particle and speed just before striking the ground. Okay, so these 5 questions you try. Now, so the important concept, see here. So the projectile motion on an inclined plane. The projectile motion on an inclined plane. So mostly in the NEET, these concept based, the projectile motion and inclined plane concept based questions are not asking. So they are not asking. So for JEE students it's important. Okay, so they might ask. Okay, so first, what does it mean by projectile motion on an inclined plane? Here 2 kinds. One is, let's suppose, inclined plane. So let's consider this is a inclined plane. So let's suppose a person is standing here and then is throwing some object from here to here. So this is called the down to top. This is a down to top projectile motion. Yes or no? He is standing here on the inclined plane and he is throwing the object at some angle theta with respect to this ground is making already an angle theta. The inclined plane with respect to the ground, this is a ground. Consider this as a ground. So with respect to the ground, so the plane is some angle, that's why it's an inclined plane, right? So then, so on the inclined plane a person is standing and is throwing the ball from down to top. So then it takes a projectile motion like this. So let's suppose he is throwing with some angle alpha with respect to the inclined plane. Okay, we'll understand in detail, just understand the basic thing. What is projectile motion on inclined plane? So that is one thing. So this is the first one. And the second case possible on the inclined plane is, so let's suppose a person is standing on the top. Consider a person is standing on the top and then he is throwing from here to here. So he is throwing a stone from here to here. So this is a ground. This is your reference point. So this is the ground. So from ground it is, let's suppose, at an angle theta, right? So the plane is at an angle theta. So now from here, so is throwing at an angle alpha with respect to this one, alpha with respect to the inclined plane. So these are the, this is the second case where top to down, this is top to down projectile motion. Done? Clear this point, everyone? Chal. So let's move further. So first we'll understand the first case, that is case 1, the down to top projectile motion. Down to top projectile motion on an inclined plane. Okay, you put the complete heading. So now see here. So first understand the basic things here. So this is a inclined plane, and then so here you are throwing some object at an angle alpha. Let's suppose the ground is making an angle, the inclined plane is making an angle theta with respect to the ground. So this is the ground, guys. So understand carefully. So bit calculations. So here theta is the inclined plane which is making an angle with the ground. So and then from inclined plane you are throwing an object, so with some speed u, with some speed u. So and then so this is, so then this take the projectile path like this, yes or no? So till now what we have done, so we know that from the ground to ground projectile motion, so when you throw an object from here, so then with some u velocity at an angle theta, so this will have two components. So one is the u cos theta and the other one is the u sin theta. So this concept we already know. So now, but here you are throwing it on the inclined plane. So for that what I am doing is I am changing the frame of reference. Here change the frame of reference. Change the frame of reference. So what does it mean by frame of reference here? The x and y axis I am going to shift. So the x and y axis I am going to shift here. So how, sir? Let's see. So I am taking the inclined plane as the x axis. I am taking the inclined plane as a x axis. Consider this as a x axis. So this is your x axis, and then perpendicular to that inclined plane, so this is going to be y axis. Just think, see here. So here the object is thrown with some u velocity. So now the frame of reference, this is my x axis and this is my y axis. So I am drawing the x axis, y axis here, see. So this is my x axis and then this is my y axis. So I am just writing these things here. So this is x axis and y axis I am writing there. Okay, so just understand carefully. So with respect to here, so this u, so that this component is going to be u cos alpha. This component is going to be, the horizontal component is going to be u cos alpha, and then here the vertical component is going to be, so the u sin alpha. The vertical component is going to be u sin alpha. So that's what I am writing here. So this is u, this is the x axis here, this is x, this is y. Just look at these dotted lines. So this is my x axis, this is y axis. Okay, so just this thing I kept it here to make you understand clearly. Okay, so then I have got, this is u sin alpha, sorry, cos alpha, and then so this part is a u sin alpha. This is u sin alpha. So clear this point, everyone? Chal. So next, what are the other things that are acting here? So the gravity on the inclined plane acts at this downward. The gravity, the acceleration due to gravity, it always acts downward. Yes. So now see, this g is neither in x plane nor in y plane. See here, this is your x plane now, this is your y and x. So it is neither in x nor in y. See here, it is some making some angle, right? So then this g also will have components. How to draw the components? The simple thing, see here, whenever a body is on the inclined plane, how do we draw the components? In the vectors concept I already discussed. So if you guys remember, so this is, let's suppose, some mass m. So then let's consider this angle is theta. So this is 90. Obviously this is going to be 90 minus theta. Yes or no? So this mg will have two components now. So what are the two components of this mg? The weight. So one component is this side, the other component is this side, the perpendicular one. So what are the components that we can write? So if it is theta, this is 90, this is 90 minus theta, this is going to be theta. Basic thing, see here, this is theta. So this is perpendicular 90. So obviously this is going to be 90 minus theta, and this whole thing should be 90, right? Perpendicular, this is perpendicular, right? So that's why this should be theta, this should be theta. So if it is theta, so the mg cos theta component will come this side. Wherever the theta is there, that side cos component will come. So this side sin component will come mg sin theta component. So in the similar way, the g is like this here. So the g is like this. See here, if it is theta, this is going to be 90. And then what is this angle? This angle is going to be 90 minus theta. This angle is going to be 90 minus theta. So now if I draw a perpendicular, the perpendicular is nothing but the y-axis. Here if I draw a line which is perpendicular like this. So if I draw a line here, so then simply this angle is going to be theta, no? This is y-axis, y-axis. So this is theta, this is 90, this angle is 90 minus theta. Obviously this will be theta. Why? Because this total angle should be 90, right? For this plane, this is a perpendicular line, so that this angle should be total 90. If it is 90 minus theta, this should be theta. So combinedly these two will give 90. Yes or no? Understanding? So that's why if theta is this side, I can say the g component, g cos theta will come this side, and then the g sin theta will come this side. Okay, remember the sin component will come along the inclined plane, the cos component will come perpendicular to the inclined plane. So the basic understanding. Okay, so the same two things I am going to represent here. So here, how do we represent? See here, this is a positive x-axis and this is a positive y-axis, and this side negative x-axis and downside negative y-axis. So in the negative y-axis I have g cos theta. In the negative y-axis we have g cos theta, and in the negative x-axis we have g sin theta. So in the negative x-axis we have g sin theta. Here we have g sin theta. So this part is clear. So right side u cos alpha, upside u sin alpha, and then so downside g cos theta and left side g sin theta. So if you understand this one, so then you can easily do what is time of flight, what is maximum height, and what is the range. So these three formulas we require, right? So again I am drawing the same diagram here. So the in the xyz, so sorry, in the xy plane, so we have got, see here, so this side we have got u cos alpha, and then this side we have got u sin alpha, and then so this side we have got g cos theta, downside we have got g cos theta, and then left side we have got g sin theta. So now let's find first what is the time of flight. So the first one I am finding is the time of flight. So for time of flight we take the y direction motion, yes or no? So for the time of flight we take the y direction motion. So let's consider the y direction motion. So in the y direction here we have the initial velocity in the y direction is going to be, the initial velocity in the y direction is u sin alpha, and then so the acceleration in the y direction is going to be, previously from ground to ground it is g, but here the g has components. What is the y component of g? Which is minus g cos theta. As it is downside, let's take it as minus, so that's why it's a minus g cos theta, right? So then so sy we know, so let the time taken be t is equals to t. So what else we required? So that's it. So sy is equals to, so uyt plus, so shall I say, so to find the time of flight, so what I am doing is, so what is the total displacement? The body is thrown from here, and then the body is reached here. That body is thrown from here, so the body is reached here. So shall I say the total displacement in the y direction is 0, because this is only in the x. In the y direction it is not traveling anywhere, right? In the y direction. So that's why simply shall I write the distance traveled in the y direction is 0. So now use the formula. So what's the formula? The sy is equals to uyt plus half ayt square. That's it. So from here, so what do we require? So we need the time of flight, right? So Sy is 0, so which is equals to Uy, U sine alpha into U sine alpha minus half G cos theta into T square. Yes or no? So into T square. So from here, so the U sine alpha is equals to so half G cos theta into T square. So from here, so T square is equals to U sine alpha, so T square is equals to U sine 2U sine alpha by G cos theta. So we need only the time of flight, right? So Ay T square. Uy is equals to U sine alpha, yes, fine. Ay is equals to minus G cos theta. So let's consider the time of flight T is equals to T, fine. So then, 1T cancels here. So just time. So this is U sine alpha into T, right here. So then here I can write U sine alpha into T is there. So the T term. So here 1T and 1T cancel. So then, so the T is equals to 2U sine alpha by G cos theta. Yes, so just I did nothing. I just substituted it in the formula. So here T is missing. See here T term is there. Okay, U sine alpha into T minus half Ay is G cos theta T square. So then you just send it to this side. So then 1T cancel. Then T is equals to 2U sine alpha by G cos theta. You need not to remember, just understand the procedure. Okay, clear? So the simple way to remember also I'll tell. This is the time of flight. So let's consider this time of flight as capital T. Consider this time of flight as capital T. Okay, understood guys this part? Check. So this is the time of flight. So can we find what is the maximum range? Understood? Any doubts here? Sir, how this Ay is minus G cos theta or Sy is 0? This doubt is there. See, when you thrown from here on the inclined plane, again it is reaching the inclined plane itself. So what is the displacement in the y? In the x it's traveled from here to here, but in the y there is no displacement, right? You thrown from here, it reached here. So what is the displacement in the y? There is no displacement in the y, right? Yes or no? Only in the x it's the displacement is there, right? Sure. So can we find the maximum range formula for the same? So let's do it here itself so that it will be easy for you. So then let's write what is the maximum range. So the maximum range. So for maximum range, what I am doing is, let's consider the y direction motion again. So let's consider the y direction motion. From where to where we'll consider? So from up to the maximum height. From here to, let's suppose this is point O, let it be point A. So consider from O to A. Consider from O to A. See here, so the initial velocity in the y direction is U sine alpha. So the final velocity in the y direction is going to be 0 because we are considering from here to here. So when it reaches the maximum height, its final velocity will be 0. Yes or no? So now Vy is 0. So then what is the acceleration in the y direction, which is going to be minus G cos theta. So now what is the displacement in the y direction? So the displacement in the y direction is nothing but h. Yes or no? So this is a height h, right? From here to here. So this is a height h which is covered because I am considering only from here to here. So then height will be h. So then simply I can use, so the v square minus u square is equals to 2as. V square minus u square is equals to 2as. So what is v square? 0 square minus u square, which is u square sine square alpha, or you can just write u sine alpha whole square is equals to 2 into what is ay? Minus G cos theta, and what is sy? The distance in the y is h, right? So then I can write here minus u square sine square alpha, which is equals to minus 2g cos theta times h. 2g cos theta times h. So here minus minus cancel. So from here, so the h max, which is equals to, so u square sine square alpha by so 2g cos theta. So 2g cos theta. This is a h max. So the simple way to remember this time of flight and the maximum height is simple. So from ground to ground projectile motion, in the ground to ground projectile motion, we know that the time of flight is equals to 2u sin theta by g. Yes or no? So what is 2u sin theta by u sin theta means the initial velocity in the y direction. So 2uy by, so g means, so from ground to ground, g acceleration due to gravity will be there only in the y direction. So in this formula you remember, I already told you in the yesterday's class. So t is equals to 2uy by gy. So now on an inclined plane you can simply write the formula. So how? Because in the inclined plane, so the time of flight will be equals to 2 into, what is the velocity in the y direction, initial velocity in the y direction, u sin alpha, 2u sin alpha by gy. What is the acceleration due to gravity in the y direction? Here g cos theta. That's it. So simply see here we got the same 2u sin alpha by g cos theta. So that's why if you remember this formula, okay, so you can easily write when you have the diagram in your mind, you can simply write this one. Done. Sure. So what about H max? So the H max from ground to ground, we know that it's going to be uy square by 2gy. Yes or no? Uy square by 2gy. Here uy means u sin alpha whole square, which is nothing but u square sin square alpha by 2gy. What is the acceleration due to gravity in the y? G cos theta. Okay, so this is the simplest way to remember. Understood? So time of flight and maximum range. So now for the case of range, so where we take the x direction motion. So here no need to remember any formula, so the derivation will be complex, but no need to remember. Okay, so just understand the procedure. So in the range, the horizontal x direction motion we consider to calculate the range. So x direction motion. So then the velocity in the x direction is u cos alpha. Initial velocity in the x direction is, remember this diagram, u cos alpha. And then, so see the ground to ground projectile motion and the projectile motion on an inclined plane, so differs here. In the ground to ground projectile motion, so the acceleration in the x direction is 0 because the velocity remains constant. But here in the case of inclined plane, so the g has two components, vertically and horizontally. So that's why the horizontal component of acceleration also exists, so which is minus g sin theta. So as it is towards the left, so that is minus g sin theta. That's it. Okay, so ux is u cos alpha, ax is minus g sin theta. And what is the total time taken from here to here? So from here to here, the total time taken will be the time of flight. So the total time taken will be the time of flight. What is the time of flight? So 2u sin alpha by g cos theta. Yes or no? So 2u sin alpha by g cos theta. So that's the total time taken. So let the time taken we have got. So use the formula. So the Sx is equals to uxt. So in place of t, just write the time of flight plus half ax t square, the time of flight square. So here the Sx is nothing but the range ux, u cos alpha, into the time of flight. What is the time of flight? So 2u sin alpha by g cos theta. Don't worry by looking at the equation. So because here the values will be given, cos alpha value they will give, alpha value they will give in the question, u value they will give in the question. You just find ux value, you will substitute it here, and then you will find theta value you know, g value you know, you will find ax, you substitute it here. Then you know alpha, you know theta, you know u, so you will find what is time of flight, and then in place of time of flight you will substitute here. So just don't afraid of the formula. So you need not to remember that, just understand the procedure, that's it. Half ax, what is ax? Minus g sin theta, so into the time of flight, which is 2u sin alpha by g cos theta whole square. This is whole square. So from here the range is equals to, I can write, so see here anything gets cancelled? No. So here 2 into u square, 2 into here u into u square. So then I write sin alpha cos alpha by g cos theta, by g cos theta. So here plus into minus, minus. So then in the denominator and numerator, so let's do one thing. So what I am doing is, so let's write so half, so g sin theta, let it be in the numerator. So here 2 square is 4 into u square sin square alpha. Let's do by the procedure itself. So 2 square 4 u square sin square alpha. So then g sin theta, let it be. So then here in the denominator, let the 2 be like that, and then this is going to be g square and then cos square theta. Okay, from here, so 1g cancel, so and then 2 1s are 2 2s are, so here cos square theta is there, so there is no cos theta in the denominator or numerator, sorry, right? Now see this one. So the range is equals to, so I can write, so here we have got, see 2u square, so let's do one thing. So let's take g cos square theta LCM. G cos square theta LCM. So here g cos theta is there, one more cos theta term is not there. So that's why it will be multiplied, no? So 2u square sin alpha cos, see basic calculations you should be clear, guys. So 2 sin alpha cos alpha and then into cos theta. So and however here g cos square theta is there, so just simply write this one. So what do we have? 2 into, so here 2 is left, so 2 into u square into, so sin theta sin square alpha, sin theta sin square alpha, sin theta sin square alpha. So then r is equals to, so here you can take 2u square and then what else is there? So sin alpha is also common, so let's take sin alpha by g cos square theta. See, this derivation is not at all important, just I am telling you the procedure. Your work is done here itself to find the range, and you just substitute it in the formula, because nobody will ask you the derivation in the exam. So they just give the values, what is the initial velocity, what is the alpha, with which angle it is thrown from the inclined angle, and then what is the inclined plane making an angle with the ground, so that they will give. So you just have to substitute the values. Just for your understanding, I am deriving this formula. Okay, so nothing else. So 2u square sin alpha by g cos square theta. So 2u square sin alpha common, so here cos alpha cos theta is left, so minus, so 2u square, here sin alpha, one sin alpha came out, so that the sin theta sin alpha remained, right? So see here, so this is of the formula 2u square sin alpha by, so here you could see that it is sin a, sorry, cos a cos b minus sin a sin b, which is cos of a plus b, yes or no? So that's why this is going to be simply the cos of what is a plus b, alpha plus theta. So the range is equals to 2u square sin alpha by g cos square theta. So this is a formula. You need not to remember, don't learn or don't remember, don't memorize. Okay, just understand the procedure. Hope you guys are clear with the projectile motion on an inclined plane from down to top, right? So this is the first case. What is the time of flight, what is the maximum range, and what is the range, right? Chal. So let me give you one question as a homework. So for today, so let's take this as a homework too, guys. Consider, let's suppose, so this is a ground. So with respect to ground, there is an inclined plane. Consider this is an inclined plane with an angle 37 degrees. So now I am throwing an object at a speed of 10 root 2 meter per second, so that it follows this path. Okay. So let's suppose it is making an angle 45 degrees. That's it. Okay. So I gave the initial velocity, I gave what is alpha, I gave what is theta. Everything you know. So now find the first question, time of flight. The second question, h max, and the third question, range. Okay. So that's a one question. And then so one more question also I can give. So let's take, so this is a ground. So the homework 3, take it as homework 3. Okay, so this is a ground. So with respect to ground, so consider this is a inclined plane which is making an angle again 37 degrees, and then so the object is thrown at an angle 53 degrees. So then it reached here. So let's suppose, so its initial velocity is some 10 meter per second. So then again find what is time of flight, what is h max, and what is range. Then hope you guys will do easily these questions. You know theta, you know alpha, you know u in both the cases. So just you have to substitute it in the formulas. So this is the first case where down to top. So now the second case, the case 2, so that is top to down. So top to down projectile motion. So where in top to down projectile motion, you can simply consider this way. So the body is making at an angle theta with respect to the ground. So the body is making an angle theta with respect to the ground. This is your inclined plane. So now you are throwing from here. Let's suppose you are throwing from here. So at a speed u. So this u will have two components. What are the two components? Let it be alpha. So then let it be so theta. So then the g will be acting downside. So the g will be acting downside. So what I am doing is I am considering this inclined plane as x-axis. Consider this inclined plane as x-axis, and then the y-axis will be like this. So this is the y-axis. So just I am drawing that x-axis, y-axis here. So this is going to be the x-axis here. This is your x-axis. So x-axis I drew here, and then the y-axis. So the y-axis here. Just shifting. So you know that if this angle is alpha, so then this side the u cos alpha will come, and then this side the u sin alpha will come. Yes or no? So the same things I am writing here. So the u cos alpha is here, and then the u sin alpha is here. U cos alpha and u sin alpha. This part is clear? Yes. So the thing is g. So g. So g will have two components because it is neither in x direction nor in y direction, right? So g is making some angle theta. So this is theta. So this is going to be 90. So this is going to be 90 minus theta, obviously, right? Yes or no? So this is theta. This is 90. This is 90 minus theta. So if you draw the perpendicular here, see here. If you draw the perpendicular, which is nothing but y-axis, perpendicular to the inclined plane is the y-axis, right? So then, so if it is 90 minus theta, this should be theta, right? This should be theta. Why? This total thing should be 90, right? Inclined plane, and this is a perpendicular. This total thing should be 90. So if it is 90 minus theta, this is theta. So obviously, so g and this side theta is there. So g cos theta term will come this side. So let me mark it with another color. So which color? Let's use pink. So this side, so the g cos theta term will come, and this side g sin theta term will come. So the only difference here it is. So the only difference here it is. So what is that? Simply the g sin theta is coming along the x direction's velocity. See here. So the g sin theta is coming along this one. So the g sin theta is supporting its velocity. That's it. When you throw from the top, obviously the velocity and g sin theta will be in the same direction. And then the other one, g cos theta is y. G cos theta is y. That's it. G cos theta is in the y direction. G sin theta is the positive x direction. Previously it is in the negative x direction. So now in the x direction, what you do is simply we know that ux is equals to u cos alpha, ax is equals to g sin theta. This is plus g sin theta this time. So in the y direction we have got, so what's that? Uy is equals to u sin alpha, and then the ay is equals to minus g cos theta. Ay is minus g cos theta. See here also the time of flight and maximum height formulas, they remain same. What's the time of flight formula? 2uy by gy. Yes or no? So 2, what is uy? U sin alpha by the gy. So what is gy? So the acceleration in the y direction, which is g cos theta. Yes or no? So the acceleration in the y is g cos theta. So this is the time of flight. So and then the h max also remains same. What is h max formula? So the h max is equals to uy square by 2g y. So from here uy square, what is uy square? U square sin square alpha, just square it, by, so 2 into uy. So what is uy? The g cos theta. That's it. So that means whether it's top to down or down to top projectile motion, the time of flight and the horizontal range, so they both will remain same. Okay, but the horizontal range differs where ax with the sign. Yes or no? Why? Because you know the ux is going to be the same, u cos alpha, but the ax, it is previously minus g sin theta from down to top projectile motion. Here it is going to be plus g sin theta. That's it. Here it's going to be plus g sin theta. So then the time of flight t is equals to simply 2u sin alpha by g cos theta, 2u sin alpha by g cos theta. And then what else is there? The distance traveled in the x direction is going to be the range. So then you will use the simple formula, Sx is equals to ux into t plus half ax into t square. So that's it. So where you will substitute the values, Sx which is range, ux which is u cos alpha, and then time of flight which is 2u sin alpha by g cos theta, and then half here plus, here it comes plus half ax. What is ax? G sin theta. And then what is t? So t in place of t, 2u sin alpha by g cos theta whole square. Everything comes same, so but here it is plus. So in the previous one, here it is minus. Where is it? Here it is minus. So but r is the last step that you get is going to be at the end. The last step that you are going to get is u square sin square alpha. That's what? Yes, u square 2u square sin alpha, sorry. The last step, if you solve this, you are going to get 2u square sin alpha by g cos theta by g cos square theta, I guess, right? By g cos square theta. So then cos of here alpha minus theta you will get. That's it. So the only difference is here previously it is minus. So then in the other case, like from top to down, so here it's going to be plus. So then here it comes plus cos alpha cos theta plus sin alpha sin theta, which is going to be reverse. So the cos of alpha minus theta you will get. So that's what I am writing here. So that's going to be the cos of alpha minus theta. Understood, guys? So this is about the projectile motion on an inclined plane. Hope you guys understood. Clear? So with this, the complete projectile motion is done. Okay. So what you guys have to do is simply write the summary as a homework. Okay. So from starting, motion in a plane chapter is very, very important. From starting, where we have started the vectors concept. So where I dealt 3 lectures for the vectors. So then I have started relative velocity. So where I have taken 2 lectures for the relative velocity, which are very, very important concept. And then I have started the projectile motion, where I have covered 3 lectures for the projectile motion. So this complete thing is a motion in a plane, and we have already covered motion in a straight line. So these 2 chapters combinedly, that's called kinematics. Okay. So what you do is you just write the summary of this kinematics division. Okay. So starting from the basic formulas, what is the distance, what is displacement, what is speed, velocity, average speed, average velocity, standard results of average speed and average velocity, all these things till the projectile motion on inclined plane. So when you write these things without seeing, so then you are said to be perfect in this chapter. So then you can focus on number of questions solving. Okay, you can take any reference book or any PW module you wish. You just have to solve the questions. Okay, try them on your own first. If you are not getting, then only go for the solutions. But first try yourself. Okay, writing the summary and short notes is very, very important at the end of every chapter. So that shows how much you are able to recall while writing the exam. Okay, you can test your recalling skills. okay, or memorizing power, how how am I remembering the old chapters. So that's very, very important. So if you don't remember the formulas, so you won't be able to answer the questions in the examination. Though you are studying on daily basis, if you are not revising, the human tendency, the human mind tendencies, everyone will forget after some time. Even me or someone else, if I don't teach for next 6 months, obviously I have to revise everything again. Yes, so that happens for all, not only for you, not only for me, for everyone it happens. Okay, so to avoid that problem, what you have to do is just revision, 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 because you are in the starting stage of class 11th, guys. So just take the advantage of that. Your seniors, ask your seniors who gave the JE and again taking the drop and preparing for this year. Ask them what's the value of time, what's the biggest mistake they committed. They'll tell you, I did not revise, I did not revise. So 70 to 80% of the students, they say, I studied daily, but I didn't allot time for the revision. So if you don't allot time for the revision, you obviously you'll forget the previous chapters. Not only physics, right? You have chemistry, you have math. If you are a biology student, you have botany, biology. Yes, so all subjects you have to cover. My role is only physics, but you have to remember all these things to crack the competitive examination, all the subjects. So that's why proper revision plan is important. While listening to the lectures, plan simultaneously on daily basis. So don't just think that when exams comes, I'll read at that time, I'll revise at that time. No, you can't do that. Okay, so something will be missed at that time. So that's something, whatever you have missed, so that will come in the examination, that's for sure. Okay, so that's why plan early revision, and then so attempt as many questions as possible on the topics you have studied. Try them on your own. If you are not getting, approach your guide or ask us, we'll also mentor you, and then do the previous year questions. So that's also very important. Chalo guys, so let's meet in the next session with a new chapter, that is laws of motion. So till then, keep studying. All the very best. Bye. Take care.